Hi, so regarding this very interesting question we have, so when will the decentralized models take over? So I would like you to think how was the situation in 1995? How did the internet and the web look like? What devices did you use? How did the PCs look like? And then you think 20 years after, how is the situation today? So this is just to have a comparison if you think about the decentralized models. We live in a very special moment today. We see that organizations are collecting enormous amounts of data, and this is by no doubt endangering our privacy and at the end also our personal freedom. 10, 15 years ago, I was thinking that was not an issue. Why? Because I was thinking, okay, so there's so much data on the internet, it's impossible for any company organization to track and profile everyone in detail. I was wrong. And we know later, since Edward Snowden, that the appetite and the capacities of organizations to track us and to profile us are almost limitless. And I also didn't see any solution at that time. But now, since, let's say, 2 years, I'm gaining more confidence. I'm seeing that solutions are being developed that can really protect our privacy, but also can help trusted companies to do their business, and maybe even in a better way. So, what is driving the change? There are, from my point of view, there are three main factors, three main drivers. One is the regulation, like GDPR and privacy. The second one is the awareness. It's a higher awareness among individuals about the importance of privacy. But let's be honest here, the situation is quite, so at the beginning it's modest. And I think that initiatives and organizations like MyData are doing a great job to promote the importance of privacy and to bring the people together to work on it, on solutions, and to develop conceptual solutions to it. And last but not least, the changes are driven also by the new technology. So definitely we have now technological means to implement use cases that were not possible to be implemented before, or were not economically viable. So let's first look at the big picture.
Could you speak a little louder?
Louder, like this?
Yes.
It's better?
Yes.
Okay.
Thank you.
So if you look at the big picture, we look at the schematic view on the personal data economy, we see that we have many actors. And each one of them needs system and application in order to participate in the ecosystem. These building blocks can be, let's say, data wallets, can be payment systems, can be identity systems, exchanges, and so on. So for some of these, or maybe for the majority of these building blocks, it makes perfect sense to see if we can use some decentralized solutions. Now, what is the main idea about the decentralization? It's about having a system working without any central authorities, without any intermediaries. And if you're looking on the schematic picture of the personal data economy, you see that we have three entities. We have data users, we have data providers, so individuals, and we have service providers that offer services either to data users or to data subjects. Now, we also have four types of transactions. We have transactions of value, like payments, we have transactions of usage rights, we have transactions of data, and we have transactions of proof of services. And interestingly, all of these transactions can be run without any intermediaries. And the promise is that we have processes that are cheaper, that are frictionless, and that allow a broader range of participants to participate in this economy. So, let's start with a simple example. It's about consent management. So consent management is one of the key functions of the personal data account. And let's imagine now the event of when an individual gives a consent to the organization, so that the organization is allowed to use the personal data. So this event can be now recorded on a decentralized ledger, on a blockchain, and it's immutable. And similarly, we can also record events of changing or revoking consents. So basically, for the whole life cycle of consent, we have a complete immutable audit trail that is also required by the regulation. So, we also see that in the whole process, in the whole life cycle, we don't need any central authority that confirms that this consent exists. So anyone with appropriate access rights, of course, can check it and see if it's there or not. But here comes maybe an interesting question. So how do you combine personal data with blockchain, which is records data mutably? Isn't this in conflict with the requirements of GDPR, so right to be forgotten? In fact, we never store personal data on a blockchain. We always store only hashes. So hash is a cryptographic code that unambiguously identifies a consent document or a consent object. And we only store this hash on the blockchain. And the document itself, or the object, is stored somewhere else off the chain. So if this document or consent object gets deleted, this hash that remains on the blockchain has no meaning whatsoever anymore. Okay? Now, another very important building block is identity. And we call identity in the decentralized space self-sovereign identities. And they have three main important points. And the first one is that from a functional point of view, an identity is seen as a superset, as a combination of different attributes related to a person. So like demographic data, age, name, address, and so on. And very importantly, social graphs, and or references to governmentally issued documents. The second proposal of self-sovereign identities is that simple questions need simple answers. So, if somebody needs to know my age, why should I show him my passport with all other information? Doesn't make sense, right? So the idea is I share only the information about my age, only this required piece of data. The third principle is that the identities should be created and managed without the need for any central authority, like certificate authorities, Google authentication systems, or things like that. So basically, the individuals can create and manage their identities, so-called decentralized identities, or DIDs, by using registers on the blockchain. Again, this eliminates the need of any central authorities. And what is also interesting, these identities can be created and managed in a not a non-expensive way. So individuals can create any DIDs that they require in order to protect their privacy. Then, next question that's interesting is where do we store our personal data? We have in principle three possibilities. One is to store the data on personal devices like mobile phones, like personal data servers, like PCs. Example for that would be CitizenMe or the Brave browser. But the majority of solutions use cloud storage. And here's an important detail. So the question is the data that's stored on the cloud storage, is it encrypted with a private key or not? If it's not, it means that the cloud storage provider can actually look into the data. Now, the third alternative are the distributed storage solutions, and they have some interesting promises. So let's compare the two of them, the last two of them. in the last 10 years, there was a widespread migration from on-premise storages to cloud storages. And this led to a massive concentration of service providers. So we have now a couple of tech giants, like Google, Amazon, Microsoft, that are dominating the market. And this comes with some interesting questions. So the first one is security. We know that every time we have a large concentration of data in one spot, this is actually representing a honeypot for hackers. And we had so many examples in the past of large data breaches. So we remember like Equifax, 60 million accounts were stolen, then FitnessPal was over 100 million, and basically every year we have a lot of these cases, and we know just from the biggest one. And probably there are millions every year, we don't really know about them. So, and the second question is, we have to put really a lot of trust in these large corporations. And you know that they're able, and they're even allowed to look into the data, to censor data or individuals, to give the data to law enforcement agencies without knowing us, and also to sell our data for commercial purposes. So, what is the alternative? Alternative are the decentralized storage solutions. And the key idea here is that the data is not stored anymore on central servers, but it's stored on a serverless infrastructure, on a network of nodes or swarms of nodes. And each each data set or file is split into small chunks. These chunks are there encrypted, replicated, and distributed across the network nodes. So what does it bring? The key benefits here is that we have a higher security. So sharding or chunking and encryption means that if somebody wants to attack the network and steal the data, it's not enough to breach into one system. The attackers have to compromise a large number of nodes in order to collect, to decrypt, to break the encryption, to collect all the pieces, and to reform the files. This is really difficult. Another important promise is that the data is censorship resistant. So there's no central instance that controls the data and has access to it. So data cannot be censored. The third promise is that we have no downtime. So if one of the nodes fails in the network, we still have replicas on other nodes. So we can still collect the pieces from other nodes and reform the file. And the fourth promise is it should be also cheaper, because these networks utilize unused capacities on storages, on computers around the world. Okay. However, we still have some concerns. Two concerns are related to the regulation, to GDPR. So one is in relation to deletion of data. So GDPR requires the rights to be forgotten. But with these solutions, we have no guarantee that a file is being deleted. We have some kind of garbage collection. So if a file or a data set is not used anymore, then it gets slowly replaced with other data. But there's no guarantee. The second problem is that there's no guarantee of where these pieces of data are being stored. So it can be stored anywhere on any computer around the world. So these are the things that the project is still working on. And we have great projects working on these decentralized solutions. We have IPFS, we have Ethereum Swarm, which we cooperate, we have Bruxelles, and Falcon are the most notable ones. Now we move to another quite interesting building block or technological solution, is so-called token curated registries. So what is it about? You know that in our everyday life, by using internet, we are constantly using this kind of different lists. So list of best restaurants, list of best movies, best books, and so on. Fact is that these lists are curated by persons or organizations that we have to trust. even if it's curated by a crowd, still these lists are subject to fraud and manipulation. So what's the alternative? These token-curated registries, or TCRs as we call it, offer a mechanism for this list to be curated by incentivizing the curators in an economical way, and there's no need that they trust each other. I'll give you an example from the space of the personal data systems, and let's look, let's assume we have a very simple data marketplace. Okay? We have the data subjects that are providing the data, and we have companies that are using the data. Now, we want to have a list of all the data subjects. Data subjects of individuals want to come to the list because they become visible to companies and for their offers. Now, they have to apply to come on the list, and for that they have to deposit a certain amount of intrinsic tokens of this TCR. And then a review period starts. Any one of other token holders can start a challenge. So I can say, oh, I don't trust this guy, I think his data is stolen. Okay? Now, this has to be proven, and then the token holders vote on the result. If the challenger wins, then the applicant loses his deposit, and the deposit is then shared between the challenger and everybody who voted for the challenge. And vice versa, if the challenger loses, so the claim is not proven, it means the deposit of the challenger is lost, or it's distributed, shared between the applicant and the token holders who voted for the application. Okay, so it's a very simple mechanism that allows that lists are being curated, get an increase in value, without any party to have to trust each other. Something similar we can do also for the list of companies that are participating on the marketplace. And the idea here is that the companies want to get on the list in order to demonstrate reputation, in order to make it transparent and promise that they will handle the data appropriately in an ethical way. Again, the application process is the same. They have to stake a certain amount of tokens. Then there's a review process where anybody can challenge the application, and the result is then gained in the same way as with the application of the data subject. But here maybe we can introduce another mechanism. It's about ranking. Maybe you want to see which are the most reputable organizations. So we introduce ranking, which is working in a similar way. So any token holder can propose an upvote or a downvote, and again it has to stake a certain amount of tokens, and anyone from other token holders can challenge it. So have the same situation, either the challenger wins or the proposer wins, the tokens can then accordingly be distributed. So the effect at the end is we have a curated list of reputable organizations that are taking care using the data in an ethical way, and also they're ranked by reputation. Now, when we're talking about personal data economy, there's one central premise, and this is that the organizations and companies give the data back to the individuals. So why would they do that? I think there are three incentives. First one is, of course, is the regulation. We have the right of data portability, so the organizations are required to give the data back if the individual so wants. The second incentive is something that I compare with real estate business. So it's sell and lease back. So we talked to a couple of companies, and they told us, look, we have so much hassle with personal data. The technical infrastructure and the organizational infrastructure to manage it is very expensive. And also we have serious risks. We have a compliance risk, and we have risk of data breaches. So just take the data and just give us access to it, so when we need it, we go and use it on demand. So this is already an economical reason. The third one is something we are researching on, and it's called data funds. And it's based on a concept of curation markets. So the idea here is that companies, organizations that give the data back to the individuals through his or her personal data wallet, in return receive a share of it in form of intrinsic tokens of this personal data wallet or data fund. Now, looking at the big picture, we see that data fund, or this personal data wallet, is interacting with other organizations, other companies. They can either give the data back and receive in return the intrinsic tokens, representing the share of the wallet, or they can use the data and possibly pay for it. So this data fund is actually generating revenues, and also is generating revenues when the data is being aggregated and anonymized and sold on the marketplaces. So these generated revenues can be then shared among the token holders of this specific data fund. So I think this is a very interesting concept you're researching on, and this is also the last example that I have for my presentation today. I hope I could give you a brief overview of what is happening, what kind of solutions that the projects are working on, and well, thank you for your attention.